Plate tectonics are the idea that the Earth's outer layer is made up of plates. These aren't dinner plates we're talking about, but the continents which have moved throughout Earth's history. You probably wouldn't even recognize Earth if you could have seen it 225 million years ago, because all of today's major continents were pieced together to form one supercontinent called Pangaea. Maybe by the heat that was warming up underneath this massive continent, Pangaea began to split apart about 200 million years ago. Our continents are still moving today. Exactly how these plates are moved is still not known. One theory is that convection within the Earth's mantle pushes the plates around, similar to the way that heat from your body rises and then deflects once it reaches the ceiling. Another idea is that gravity is pulling the colder, older, and heavier ocean floor with greater force than the newer, lighter floor. Whatever it is that drives the movement, the activity takes place at three different boundaries: divergent boundaries, where the Earth's new crust is formed; convergent boundaries, where the crust is consumed; and transform boundaries, where two plates slide against each other. There are a few types of convergence, but we will be focusing on subduction. In subduction, an oceanic plate hits a continental plate, pushing the oceanic plate underneath into the hot mantle, which melts as it enters. At a subduction zone, there is usually a trench to mark it. Most of the time, subduction also causes a volcano to form, fueled by the melting plate's pressure. Weathering is the breakdown of materials through direct contact of the Earth's atmosphere. There are four main types of weathering. The first is called freeze-thaw. Most rocks are solid and difficult to break, but a tiny bit of water can do the trick. Water can seep into small cracks in the rocks and freeze. When water freezes, it expands. Repeated action can eventually break rocks apart. The next type is called exfoliation, or onion skin weathering. It is very common in warm areas. When the sun shines on a rock, it expands. When night comes, it gets colder, which causes the rock to contract or shrink. Over time, that will cause the outer layer to flake off. Next, there is chemical weathering. This is where there is an alteration to the chemical composition of the rock. This happens because of a reaction with water and rock. Since water is slightly acidic, it can dissolve rock. This is a very slow process. Finally, there is biological weathering. This is the effect of living things. A good example is when a tree grows, its roots move, causing them to break the rock around them. It also occurs on a much smaller scale with moss and fungus. Erosion is the process by which soil and rock are removed from the Earth's surface by exogenetic processes, such as wind or water flow, and then transported and deposited in other locations. While erosion is a natural process, human activities have increased by 10 to 40 times the rate at which erosion is occurring globally. Excessive erosion causes problems such as desertification, decreases in agricultural productivity due to land degradation, sedimentation of waterways, and ecological collapse due to loss of the nutrient-rich upper soil layers. Water and wind erosion are now the two primary causes of land degradation. Combined, They are responsible for 84% of degraded acreage, making excessive erosion one of the most significant global environmental problems. There are 4 primary types of erosion that occur as a direct result of rainfall: splash erosion, sheet erosion, rill erosion, and gully erosion. Splash erosion is generally seen as the first and least severe stage in the soil erosion process, which is followed by sheet erosion, then rill erosion, and finally gully erosion, the most severe of the 4. We will focus on gully erosion. Gully erosion occurs when runoff water accumulates and then rapidly flows in narrow channels during or immediately after heavy rains or melting snow, removing soil to a considerable depth. A volcano is a hollow vent in the Earth's surface through which hot molten rock, called magma, along with some gases and hot ash, oozes out from the Earth's interior. Volcanoes are formed by upwelling of magma deep under the Earth's surface. No one is quite sure why magma rises in certain areas, but when it does, it forms pockets which create pressure on the rock of the Earth's crust. When the pressure inside these pockets becomes sufficiently large, the magma forces itself through the crust to the surface of the Earth and spills out as lava. If the crust above the magma pocket is relatively weak or has re-established channels for the magma to flow through, the magma will erupt relatively gently and form shield volcanoes, such as the Mauna Loa volcano in Hawaii or the undersea volcanoes on the Atlantic Rift. When the crust is relatively solid, however, lava may force its way up for a while, building a pyramidal volcano around its main channel. This channel will eventually become blocked by solidified lava, and pressure will build to a much greater level, creating more violent eruptions when it releases, as happened with Mount St. Helens and Krakatoa. Shield volcanoes are some of the largest volcanoes in the world. They form like any volcano, where there are spots on the Earth where magma from inside the Earth has reached the surface. Over time, the continuous eruptions of magma build up layer by layer until the magma pocket underneath runs out and the volcano becomes dormant. The big difference is that shield volcanoes are made by very slow-moving magma flows, sort of like liquids. Since water is very runny, it has a low viscosity. On the other hand, syrup has a high viscosity and flows slowly. It is same for volcanoes. The shape of the volcano can affect viscosity of the magma. For shield volcanoes, the lava can flow easily for many miles, creating sloping slides. Shield volcanoes are generally safer than other types because they don't typically explode, and the lava flows are easy to avoid. Mountains are formed by movements of the huge tectonic plates that make up Earth's crust, and they are built through a general process of deformation of the crust of the Earth. Deformation also means folding. Folded mountains are formed when 2 plates collide. Block mountains occur when a slab of land is forced upward. Volcanic mountains are built up from layers of cooled and hardened lava and ash. When 2 sections of the Earth's lithosphere collide, rather than being subducted, where one slab of lithosphere is forced down to deeper regions of the Earth, the slabs pile onto each other, causing one or both slabs can fold up like an accordion. This process elevates the crust, folds and deforms it heavily, and produces a mountain range. Mountain building and mantle subduction usually go together. Folded mountains are formed when two plates crash into each other, which forces the plates to fold and ripple in the middle. It's like pushing a rug up against a wall, creating the same effect. A few folded mountain ranges are the Appalachians, the Swiss Alps, the Zagros Mountains in Iran, and the Atlas Mountains of northern Africa.